Okay, this is number 6 of the homework problems on cross-sectional volumes with integrals. Now, these problems, number 5, 6, and 7, and I think 8, they're using the same equations. So we've already drawn this on the previous problem, so I'm just going to reduplicate it here. This is y equals x, and the parabola looks like this. And we know that it intercepts here at, I think, -1, and it goes all the way to 3. Now, in the previous problem, we did squares, or they look like, I guess, pieces of bread being sliced. Here, we're going to use equilateral triangles. Oh my goodness, this is crazy. Okay, equilateral triangles that are perpendicular to the x-axis. Great. Okay, so how do we do this? All right, so here is the base of my equilateral triangle, okay, on the ground. So this is on the ground. Now I'm going to attempt to draw this figure. So it's equilateral. So technically, okay, does not look like an equilateral triangle, but okay, let me draw that again. So let's see. Okay, that's a little bit better. Okay. All right, so basically they're like half sandwiches. They're equilateral triangles. This is placed on top of this, where this base is basically that, okay? And we want to find the volume of this figure and come up with an integral to represent theoretically all the thinly sliced wedges and adding it up from 1 to all the way up to what? 3. Now, again, with the problem that we did before, we know what the integral is going to look like. It's going to be -1 to 3. We need to find the volume of that figure and d what? And dx. Actually, no, this would be your base. So the area of the base times what? Height. So let me start that again. Volume of any prism is area of the base times height. As I told you again and again, you have to put this figure facing down on the ground for this equation to actually make sense, because here the height is not the height of this equilateral triangle. The height of the prism is right over here. Okay, this is my height, and if you put that on this graph, that height is right over here, which happens to be a dx value, the change of your x values, because it's perpendicular to your x-axis. Okay, so we'll call this dx. All right, so how do we draw this? Well, easy. So again, so let me draw this portion right over here, and I'm going to draw it like this. Okay, does that make sense? It's kind of pushed down. Okay, so this right here is my height, as it were, and this right here, the top and bottom, are called my base. And so volume of all prisms in this sense is b times h. And again, h is dx, so we know that. So the real question is, what is the area of the equilateral triangle? Now this is where it gets kind of complicated, because now you have to just sort of leave everything behind and figure out how to find the area of a equilateral triangle, which is not as simple as it looks, because it's equilateral. There's no height. You have to find your height there. Okay, so let me redraw this, and I'm going to draw this with the yellow color like this and say, okay, we're looking for the area of that equilateral triangle, which happens to be this right over what? Right over there. Okay, so I'm going to just draw it to the side. This is an equilateral triangle. Equilateral triangles means all three sides are exactly the same, and all three angles are 60, 60, and 60. So how do we find the area of this? Well, we need to find, okay, so let's just kind of label this right here with the letter. We'll call that, I don't want to use base because there's so many words, there's so many bases. We'll call this, just call it M, okay? Right, so let's just call it M. So because, it's going to be M all the way around. Okay, so this would be M, okay, M distance long. But if I want to find the height of this triangle, okay, like that, I have to figure out how to represent that in terms of M. So we know the general area of a triangle. So it's 1/2 base times what? Height for this picture. Okay, so that's why this is so confusing, because this height only represents this two-dimensional figure. This height represents the height of this three-dimensional prism. Let that sink in a little bit. Okay, so let's fill this out as much as we can. What do we have? So we have area equals 1/2. Well, my base is going to be the letter M. Okay. Well, what about my height? Well, let's see. This is where you have to know your 30, 60, 90 triangle shortcut. This goes back to your algebra 2 and geometry days. Okay. That triangle right there is my 30, 60, 90 triangle. This portion right here will be M divided by 2. Okay, M divided by 2. And to find the missing side, if you use the 30, 60, 90 shortcut, this will be M divided by 2 times radical 3. So the height is M divided by 3. I'm sorry, M divided by 2. M divided by 2 radical 3. Now, before you hit rewind and go back and try to figure everything out, let me just explain to you this on the side, okay? So in algebra 2, you should remember this. When you have a special 90-degree triangle called a 30 degrees, wait, sorry, this will be my 30, 60, and 90 triangle. If one of the sides happens to be like the letter P, the side opposite of 30 will be the smallest side. The hypotenuse is always double that, so it's 2P. Okay, I'm just using P as a general designation. Based on P, the side opposite of 60 degrees, which is like the medium side, all you have to do is multiply by radical 3. Okay, and that's what I'm doing. This triangle right here, the actual width is 3, or the actual leg of the equilateral triangle is 3, M. We cut that in half so we can work with this figure right over here. That's M over 2. To find the side opposite of 60 degrees, it's M over 2 radical 3. Okay. Is there like a short equation for equilateral triangle? I think there is. I don't know it offhand, but let me look it up. Area of a equilateral triangle. Area of equilateral triangle. Okay, let's see. Oh yeah, okay. So now I like to derive things by hand, as you can see, because I just don't want to memorize so many things. So, but here's an equation for equilateral triangle. You can memorize this, and if it's on the test, you should definitely triangle area. Area of equilateral triangle, it's area equals radical 3 over 4a squared. Wow, that makes it much easier. And you'll notice that if I finish doing this, it turns into this. You see the 4, 2 times 2 is 4. M times M is basically a squared radical 3. Okay, so I derived it for you, but here it is. You can just use this one. So area is equal to radical 3. M is, what's our M? Okay. Now we have to go back and find our M. We haven't found the actual distance yet. Okay, for whatever it is, all we have to put is right here. Okay, all we have to do is plug in M into this little parenthesis, square it, and we have our area of the base. So now let's go back to our picture. How do we find this length right here, which we've designated as the letter what? The letter M. It's the same thing for the previous problem. It's going to be y2 minus y1. So I'm going to go over here and just write it as M equals y2 minus y1, which is, what's y2x minus x squared minus x minus 3. Ugh, my handwriting. So this is x minus x squared plus x plus 3. And again, just simplify everything out. This will become negative x squared plus 2x plus 3. So this is one side of my equilateral triangle. All you have to do now is take that, plug it into, obviously, this equation A, which we're going to call it right over what? Right there. So negative x squared plus 2x plus 3. Okay. All right, so let me just rewrite that just to make it look a little bit nicer. So area of the equilateral triangle is radical 3 parenthesis negative x squared plus 2x plus 3 squared divided by 4. That is the area of my what? Of my base, which I need to plug in right over here. Now this is my volume formula. So let me bring that all the way down here. So the volume is equal to area of the base times height. The area of the base is radical 3 negative x squared plus 2x plus 3 squared over 4 times d what? Times dx. Okay? And again, all we do is just slap on the integral symbol, and we're going to go from negative 1 to what? To 3. As we see here, so negative 1 to 3 of a bunch of thinly sliced equilateral triangle prisms. And again, this is a calculator problem, so just type it in carefully. And what do we have? Okay, this is always nerve-wracking because I think I did it right, and then you plug it in wrong and you get the wrong answer. You gotta start all over again. Okay, so here's lower bound 3 and then square root of 3. Okay, left parenthesis, oops, left parenthesis negative x squared plus 2x plus 3 and dx. Did I write everything quickly? Negative 1 to 3, square root of 3, negative x squared plus 2x plus 3 dx, and enter. And we got volume equals 18.7475. And the answer key says 14.78. Wait, am I looking at the wrong one? What number is this? 6. The answer is 14.78. What did I do wrong? Okay, so did I? Oh my goodness. I forgot. See, on my calculator, I did not include the square. Ooh, okay, so let me go back and edit this. So I'm going to, wait, how do I do this? I need to copy this. How do I copy this? Oh yeah, second menu. Yes, copy, second menu, paste, go back and plug in the squared, which is right here. Enter. 59. I got it wrong again. Why? Wait, 14. I think he's wrong. I think my answer is right. No, I did it. What did I do wrong here? Did I plug it in correctly? Negative x squared plus 2x plus 3. Oh my gosh! I forgot to put a 4. Okay. So the point of this exercise is don't do what I'm doing. Okay, plug it in carefully. So my first problem was I didn't plug in the 2 correctly. Second problem, I didn't plug in the 4. Oh, you know what I can do? It's just a constant, so I'm going to take my answer divided by 4. 14.78. There it is. Okay. The reason why I made that face, that funny looking face, was I didn't want to have to record this from scratch. Anyways, here it is. Okay. So yes, I did it correctly. I just didn't punch it into my calculator. I hate this calculator, by the way. Okay, so there's your answer. Let's move on to the next one. Have a good day.